Okay, so if we have a basic understanding of what atoms and molecules are, the last thing to do is just to get a very, very basic sense of how atoms and molecules behave. And so to do that, we'll just think about the phases of matter and also temperature. The phases of matter refer to whether a piece of matter is in a solid, liquid, or gaseous state. Molecules that are in these different states behave differently essentially because of their movement. And this is something that a lot of us learn and is probably pretty obvious. In solids, molecules are locked together rigidly. They cannot move forward or backwards in space. In liquids, there is some movement allowed. Gravity pulls the liquids down, and liquids conform to the shape of any container that they're put into for that reason. But molecules in a liquid both bond to each other and separate from each other. And so what you end up getting is a constant bonding and separating, and so you end up with these substances that hold together in some situations, but fall apart in other situations. Gases are gases are substances where the molecules have the most freedom of movement. The molecules have a lot of energy in them, and they can separate from each other and completely fill whatever space they're put in, even working against gravity. So if you have a large room and you let some small particles of gas out into that room, those particles of gas will diffuse throughout the entire room until there's an even distribution of that gas throughout the room. If you think about the Earth as like one large room, and you think about the gases that make up our atmosphere, those gases diffuse all throughout Earth's atmosphere until they're in even distribution. So you couldn't be in a certain part of the Earth and experience, there wouldn't be more oxygen or less oxygen in one part of the world just because of concentrations of gases. Now there would be more or less oxygen in certain parts of the world depending on your elevation, but that has to do with how concentrated gases are at sea level compared to at elevation. But generally speaking, at the same elevation, gases completely diffuse. So we know generally how molecules move inside of gases, liquids, and solids, but I wanted to just make one last point. There's a really fantastic video that can be looked up of Richard Fineman in his later years talking about imagining atoms and molecules and the power of imagining atoms and molecules and what that can do for allowing us to understand scientific concepts more deeply. He gives a really simple example where he talks about a coffee cup and the liquid inside the coffee cup as a way for us to think about how atoms and molecules interact. And he talks about temperature. So temperature, all temperature really is, all hot and cold really are the vibrational energy that atoms or molecules have. When I take hot water out of the kettle, the water has a lot of vibrational energy inside of it. I've just added a lot of energy to it by heating it up. And when I pour that hot water into my coffee cup, the energy from the water molecules vibrating is going to start to vibrate the molecules in the coffee cup. That's why as I hold the coffee cup with hot liquid inside of it, the coffee cup itself gets hot. Now, what we have to imagine here is even though the water molecules are liquid and are able to move around, the solid molecules in the coffee cup, they're not able to move positions. The molecules that make up this part of the cup, say, can't move up and down. But all molecules, whether they're locked in a solid, whether they're in a liquid or a gas, have the ability to vibrate. And that vibrational energy is really what we experience as temperature. Lower vibrational energy translates to colder temperatures, what we feel as colder temperatures, and higher vibrational energy translates to hotter temperatures. So really, when we feel a hot coffee cup, what we're feeling is the vibrational energy in the molecules that make up that cup transferred from the vibrational energy of the water, the hot water, or the hot coffee inside of that cup. Thanks for watching this episode of Tutor This. As always, if you have questions or suggestions for future episodes, leave them in the comments below. Remember to click the like button below, and if you enjoyed this video and want to see more like it, hit subscribe.